Let's open the Flask Python script on my server side. I'm using Python Anywhere hosting service for this. Let's get the required imports first. The Android client we wrote is going to send data in JSON format. We also need Python imaging library or PIL services to add image processing to our Python Flask script. Next, let's map our URL for HTTP post to a Python function. This function will handle the logic of receiving the image from our Android client as a JSON payload and machine learning related image processing with OpenCV and Numpy. We'll abort with an HTTP 406 error response if the payload is not valid JSON or if the JSON key img is not present in the JSON. Remember that the JSON key img points to the base64 encoded image file content which we want to retrieve here. If all looks good, then we will access the img key to access the payload and decode the data from base64 encoding into bytes. Then we will instantiate a Python imaging library object from the decoded bytes. We will write the decoded bytes to the server's file system. This should restore the image contents into the original binary format of a PNG image file. Let's get a Numpy array from the PIL image object and using OpenCV obtain a Numpy array from the PNG, a file that we just saved to the server's file system. We are using flag 0 in imread to load the image in grayscale. The array shapes should be the same for the PIL image and the PNG file in the file system if the image was transmitted and captured correctly. We will check this after we run the app and generate some logs. Okay, some code fixes here. Let's reload the website, which will compile our Python Flask script. Now let's go to Android Studio, launch the APK there. Let's press this button here, which should set off the process showing on your screen. That is, grab a PNG file from device storage, encode it in base64 and send it to server via HTTP post. Looks like we got a success response from the server. Let's check these server logs. Looks like the server handled the HTTP post without errors. We can see that the Numpy array shapes for the PIL image and the PNG file in the file system are the same. This serves as a validation that the PNG image was transmitted by Android program on the phone and processed by OpenCV on the server correctly. I have shared the code in the description box below. So in summary, we have shown a way to use the power of OpenCV image processing and machine learning by distributing the load between an Android phone and the server side, where the real power of OpenCV, Python imaging libraries, and Numpy can be unleashed for heavier machine learning. Hey, give us a like if you found the content useful. Please share with your friends and let us know in your comments if there's something we can improve on, or if there is another topic you want us to make a video on. Help us reach our channel to more viewers who could find our content useful. Peace.